The paper of the day is Frangipani, a scalable distributed file system. The ideal distributed file system will provide all its users with coherent, shared access to the same set of files, yet would be arbitrarily scalable to provide more storage space and higher performance to a growing user community. It would be highly available in spite of component failures. It would require minimal human administration, and administration would not become more complex as more components were added. Frangipani is a new file system that approximates this ideal, yet was relatively easy to build because of its two-layer structure. The lower layer is called Petal, which is described in an earlier paper, a distributed storage service that provides incrementally scalable, highly available, and automatically managed virtual disks. In the upper layer, multiple machines run the same Frangipani file system code on top of a shared Petal virtual disk, using a distributed log service to ensure coherence. Frangipani is meant to run in a cluster of machines that are under a common administration and can communicate securely. Thus, the machines trust one another, and the shared virtual disk approach is practical. Of course, a Frangipani file system can be exported to untrusted machines using ordinary network file access protocols. Benchmarks. This paper used a couple of key benchmarks. One is Andrew benchmark, a widely used file system benchmark. The first phase of the benchmark creates a tree of directories. The second phase copies a 350 kilobytes collection of C source files into the tree. The third phase traverses the new tree and examines the status of each file and directory. And the fourth phase reads every file in the new tree. The fifth phase compiles and links the files. The second benchmark is the Connectathon benchmark, which tests individual operations or small groups of related operations, providing more insight into the source of the differences that are visible in the Andrew benchmark. Like the Andrew benchmark, this benchmark also does not account for deferred work. So again, they unmounted the file system at the end of each phase. Comparison with GFS. GFS is highly available, fault tolerant, low latency, huge chunk size that suits frequent reads and appends, and has weaker consistency model. It runs on application level. Frangipani is easy to scale because of its modular nature and virtual disk, that is called Petal. It has stronger consistency through distributed log service, and it runs at the kernel level. Let's look at the contributions of this paper. So this paper presents Frangipani, its two-layer distributed file system. It has a Petal, which is the distributed storage service, is focused on clustered systems, and it has a distributed log service to achieve cache coherence. The key takeaways from this paper are the whole Frangipani system. It's easy to add, delete, and recover servers, storing log information on the virtual disk, simplified deployment of Frangipani. The drawbacks are disks are opaque to the file system. Fragmentation of physical disks can happen because of 64 KB commit block size, and separating inodes and data blocks completely might result in performance hit. Let's talk PS score for this paper. Overall, this paper is pretty good read, so it gets 9 out of 10 on readability. With 14 pages long, it scores 8 out of 10 on length. It's an analysis of an existing system with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is pretty high, so it gets 9 out of 10 on each, with overall PS score of 9 out of 10.